Welcome Meyer, 4th grade math. Today we're going to be talking about lines of symmetry. Lines of symmetry come to us with standard 4, geometry 3. Let's get to it. Some important vocabulary for you to know as you move into this section. A line of symmetry is a line along which a shape can be folded to make a mirror image. So when it's folded, it will identically match the opposite side. Here we have two different 5-sided shapes. We have this one that kind of looks like a house. If we draw a line of symmetry, which is typically drawn with some dashed lines, if we folded this house in half, both sides would equally match. This line would match up here, the sides would match together, the bottoms would come together to meet. So this particular image here has one line of symmetry. Moving to this 5-sided shape, there's not equal sides, similar to this one. However, if we were to fold it in half, because of this corner that's cut differently, it would not match identically, no matter which way we folded it. If we folded it with a line of symmetry down the center here, or here, it would not match. So those are the differences between images with a line of symmetry versus no lines of symmetry. Some things to consider. Some shapes have multiple lines of symmetry. We can see here in this middle image, which is kind of like a cross, if we folded it down vertically down the center, we would have a line of symmetry. If we folded it horizontally, we would have a line of symmetry. So it's okay if some shapes have more than one line of symmetry. You may notice one over the other first. It just depends. Here I have a couple other images to just take into consideration. Something like a circle. A circle has many lines of symmetry. No matter which way you decide to fold it, it will match up. So it kind of goes on infinitely more than what I've even shown here, but think of circles as the ultimate lines of symmetry. Something like a star, depending on how it's drawn, it can match at least one way. So just make sure that you take into consideration for images like stars, how it's drawn, if the points of the star match, how many points of the stars there are. With something like a 5-pointed star, there's most likely only going to be one line of symmetry. With something like an 8 or a 6-pointed star, you potentially have more because you could match both points on each side. Moving down, some of us aren't visual learners, so something like symmetry can be a little bit tricky. So if you are having trouble visualizing symmetry, the best tip I can give you is to cut out the shape and test it on your own. So let's do a few of these, and kind of made a chart here for us, symmetrical versus not. And I've chosen a few different images that are from your activity, and we're going to place these into this graph. The first is an arrow. And clearly if we fold it like that, we have no match. If we fold it horizontally, both the back end of this arrow and the front end of this arrow, and if we flip it over, we can see that it matches exactly. So something like this arrow, we're going to place into the symmetrical station. Okay. Next image. We have a interestingly shaped quadrilateral. Once again, we can try to fold it in different ways. Here we see that the corner is sticking out, doesn't make a match. We can try again, long ways. Still the corner is sticking out. Because of that unique angle there, we don't have a symmetrical shape. So we're going to put that in the not pile. Next, a fun little diamond. So here we can try a few different ways. Well, looks like we definitely have a symmetrical shape. And in fact, it might have more than one line of symmetry. It has two, definitely. So I'm absolutely going to place my diamond into the symmetrical shape pile. Lastly, something I want to talk with you about is shapes that are right triangles. These can sometimes be tricky to evaluate. Couple things that you might want to pull from your memory. There are 3 different types of triangles. There's equilateral, all sides are equal, but right triangles are never equilateral. There are also isosceles triangles. 2 sides are the same length, one is longer. And then there's finally scalene triangles. All sides are of different lengths. This particular right triangle is a scalene. And as you'll notice, when I try to fold it, we have a point of that triangle sticking out, meaning telling us this is not symmetrical. However, if I was to draw an isosceles triangle, and let's just say this side of the triangle and this side of the triangle were the same length, we would have a symmetrical right triangle. So it's something that you can always cut out, evaluate, maybe get out a ruler to help you determine the best answer for a right triangle. In this particular situation, it's a scalene triangle, so we're going to put it in the not pile. And that's all I have for you today in regards to symmetry. Thanks for watching. Your assignment is 4G3 Interactive Notebook. On the notebook, just make sure that you're moving the different dashed lines and the circles to the appropriate shapes. And if you have any questions, hello, forgot the A on my own name. If you have any questions, reach out to Miss Mendoza, Miss Lass, or Mr. V. Thanks for tuning in, guys, and have a great week. See you next time. Bye-bye.